Hello everyone, my name is Rupert Rodriguez. Today I will be showing you the solution to problem number 17 on journal review number 2. So we are given a set of polynomials and we are asked to show that this set of polynomials is the basis for P3. And the way we're going to do this is through isomorphism. So an isomorphism is an invertible linear transformation. And if there exists an invertible linear transformation between two linear spaces, we say that those linear spaces are isomorphic to each other. And isomorphism is important because it shows that they have a similar structure. And so the way we're going to find this isomorphism is by first finding the standard basis for our polynomials. So here I've written down one of the standard basis you use. So it's 1x, x squared, and x cubed. And pretty much what we're going to do is we're going to take our polynomials and we're going to express them in terms of c, so c1 through c4, that can then be multiplied by our standard basis to then return to these polynomials. So as you can see, for x cubed minus x squared minus 5x plus 1, we see a c1 of 1, a c2 of negative 5, a c3 of negative 1, and a c4 of 1. And we express them as this matrix here. So then we're going to do this for all of our polynomials. This is just one example, but you can see how it follows through. You essentially just take the leading coefficient that, when multiplied by the value in the standard basis, would then return this value here. So you find that, and you find that for all of your polynomials, and then you can combine them into a matrix. And so what we're going to do is we have this matrix A, and this is our linear transformation. This is our isomorphism. And so what we're going to do is we're going to take this and we're actually going to row reduce it. And then we're going to see if this matrix forms a basis. And if this matrix forms a basis in R4, then by isomorphism, we're going to show that the set forms a basis in P3. So here's how you would do the row reduce echelon form. I'm just going to assume that you already know how to do this or that you can do this by hand. So I use this calculator here. You can access it at this website. It'll be in the description if you want it. And we see that the row reduced echelon form is the identity matrix. But more importantly, we see that these columns are all linearly independent. So that means that there's no combination of the other columns that can equal one column, right? So I cannot express column 1 as a linear combination of columns 2, columns 3, or column 4. And that's for all of the columns. So we say that this matrix A forms a basis of R4. And by isomorphism of R4 to P3, the set U forms a basis of P3. And with that, we conclude our solution. I hope you enjoyed.